Now we want to look at the degraded broadcast channel, which I showed you before. So in this case, we have again an encoder which encode a common message and two dedicated message. The sequence he encoded goes over a channel from X to Y1. Y1 goes to decoder 1 and sync 1, but then Y1 goes through a second channel, which goes to Y2 and decoder 2. We want to estimate also the common message and his dedicated message. This channel is called the physical degraded broadcast channel. We can generalize this because of the property we proved before, because we can generalize this to the so-called stochastical degraded broadcast channel. We call a channel stochastically degraded if it has the same marginals, that means marginal channel from X to Y1 and from X to Y2, as some physically degraded channel. We can write this also in this form. To look at this, we can look at these pictures. So physical degraded means that we have this situation here. We have a channel from X to Y1, then from Y1 to Y2. This is called physically degraded. It's called stochastically degraded if we have the same marginal. That means we have here a channel, and we have here a channel to Y2, and the marginals are the same like in a physical degraded channel. Now let's look at the rate region. Therefore, I open a whiteboard for you. So just wait, I open a whiteboard for you and remind you on the result we have before. So for superposition coding, we showed the following rate region, which is achievable. We showed that the following rate region is achievable. We choose 0, lesser equal R0, lesser equal the mutual information between U and Y2. Furthermore, we have 0 is lesser equal R1 is lesser equal the mutual information between X and Y1 under the condition U. And we have 0 is lesser equal R0 plus R1 is lesser equal the mutual information between X and Y1. First thing what we did, we saw if we generalize this, so this was the result if we have a common message and a dedicated message for decoder 1. Then we discussed that we can use R0 also to send a dedicated message to decoder 2. Therefore, we replace R0 by R0 plus R2. So we get here also R0 plus R2 here. Now, in the degraded case, we have some special properties. So this is a general rate region for superposition coding with one common message and two dedicated messages, as we have proved. But now we look at the degraded channel. For the physical degraded channel, the following property holds by the data processing lemma. So we knew that the mutual information between U and Y2 is lesser equal than the mutual information between U and Y1. So that means we can write here the sum. What I want to show now that we only for the physical degraded broadcast channel, and therefore also for the stochastical degraded broadcast channel, we just need the first two properties, because I will show with this property here the third property follows. So let's look at the sum from R0 plus R2 plus R1. Of course, we can estimate this by the mutual information between U and Y2, but this is lesser to the mutual information of U and Y1. And plus R1 is lesser equal than the mutual information between X y1 under the condition u. But this is equal to the mutual information between x and y1. Therefore, you see, together with the property, this property here of the degraded broadcast channel, properties we follow. That means the rate region we have for the degraded broadcast channel with superposition coding is just this one here. Okay, let's look again at the slides. So here it's written what I just showed you. For the degraded broadcast channel, we have this property here, and therefore this holds. But this we get by the estimation. Therefore, the resulting set is just this rate region here. So the rate R0 greater equal 0, R1 greater equal 0, and R2 greater equal 0, we have these two properties here. R1 is lesser equal to the mutual information of x and y1 under the condition u, and R0 plus R2 is lesser equal to the mutual information between u and y2. And so the capacity region, that means we also know an upper bound, is just the union over all probability distribution of u and x. Remember that this probability distribution we could choose as we want, and this rate region R P ux. And it's shown that this is also the capacity.